if he were to step down, he could crush a tank into scrap metal. You heard that right. This isn't a sci-fi movie. This is a creature that truly existed. He is called Argentinosaurus, weighing 100 tons. He is equivalent to 17 African elephants stacked together. But what's even more outrageous is, he might not even be the largest. Scientists estimate that even larger creatures may have existed on Earth. Their bones simply haven't been found yet. In 1987, in Patagonia, Argentina, a farmer tripped in his own field. He looked down, thinking it was just a piece of rotten wood. However, after paleontologists arrived, they stood in silence for 3 whole minutes, because that wood was actually a tibia, taller than a grown man. And by the time they finished excavating the entire skeleton, everyone realized that the textbooks would have to be rewritten. When this thing was alive, his heart alone weighed a full ton. With every single beat, it had to pump 200 liters of blood throughout his body. But here comes the most terrifying question. For such a massive monster, how on earth did he go extinct? Don't be in a hurry to answer that just yet. Let's first clarify one thing. Just how big was Argentinosaurus? Because the image currently in your mind is likely far from reality. A single section of his vertebrae is over 1.5 meters high, taller than the refrigerator in your home. A single rib is nearly 3 meters long. If you lay down on it, your whole body wouldn't even cover it. His femur, which is the thigh bone, is 2.4 meters long. With a diameter of nearly 50 centimeters, you couldn't even wrap your arms around it. But the most mind-blowing part isn't these numbers. It's his neck. The neck of Argentinosaurus exceeded 10 meters in length, equivalent to the height of a 3-story building. If he just stood there without moving, his head would already be suspended high in the air, looking down upon the entire forest. He didn't need to walk over. He only had to stretch his neck, and every treetop within a 10-meter radius became his dinner table. You might think this is an advantage, but scientists discovered a problem that makes one's skin crawl. With such a long neck, how was blood transported to the brain? For a normal animal's heart, pumping blood up a meter or 2 is enough. But the heart of Argentinosaurus had to pump blood vertically to a height of nearly 10 meters. This pressure is equivalent to you using a thin pipe to pressure water up to the roof of a 3-story building. An ordinary heart simply couldn't do it. Either the heart was impossibly large, or the blood pressure was high enough to burst. Vascular scientists debated this for decades, before finally reaching a conclusion. The heart of Argentinosaurus might not have been just one. Some researchers believe that within his neck vessels, there existed a set of special structures to assist in pumping blood. It's like having several small booster pumps extrainstalled within his neck, specifically responsible for pushing the blood up section by section. This wasn't just an animal. It was a precision hydraulic machine. But even more incredible than his heart were his bones. You surely think that, with a weight of 100 tons, the bones must be as thick as stone pillars, solid and as hard as steel. You are completely wrong. The skeleton of Argentinosaurus was hollow. Not the thin kind of hollow, but a honeycomb-like support structure inside. The outer walls were only 8 centimeters thick, but every internal support strut was precisely aligned along the direction of stress. Just like the truss structures in modern architecture, it used the minimum amount of material to withstand maximum pressure. Scientists took this structure and compared it to the hull design of a modern aircraft carrier, finding that the mechanical principles of both were almost identical. In other words, 95 million years ago, nature had already independently invented the engineering that took humans thousands of years to understand. Even more amazing were his legs. Inside the forelegs, there was no solid marrow, but instead, they were filled with cartilage that could adjust pressure. With every step he took, the body fluids acted like hydraulic buffers, instantly dispersing the force of impact. Scientists performed mechanical simulations. The ground pressure of each of Argentinosaurus steps was actually only 1/3 of that of an adult adult elephant. A 100-ton monster walking lighter than an elephant on the ground. Wouldn't you say that's like using a cheat code? Now, let's talk about how he ate. Because this is the part that is truly how much energy does a 100-ton body need to consume daily? Scientists estimate that Argentinosaurus had to eat at least nearly a ton of plants every day, just to maintain basic life functions. 1 ton is 1,000 kilograms, meaning every day, a weight of leaves equivalent to a small car had to be stuffed into his stomach. But here's the problem. His teeth couldn't chew at all. The teeth of Argentinosaurus were a row of small, peg-like teeth, which could only be used to strip plants, not to masticate. He couldn't grind them down. Everything he ate was basically swallowed whole, branch by branch. So how did he digest it? The answer is that he would intentionally swallow stones. In several fossils of sauropod dinosaurs, gastroliths have been found, which are small stones polished smooth. These stones would constantly tumble in the stomach, grinding down the swallowed plants. It was equivalent to having a never-ending grinder installed in his belly, and his stomach volume exceeded 5 cubic meters, housing billions of symbiotic fermenting bacteria. His digestive efficiency was 3 times that of a modern cow. Food went in. The bacteria fermented it. The stones ground it. And the 400-meter-long intestinal tract slowly absorbed it. The whole process was like a mobile biological chemical plant. He wasn't just eating. He was using his entire body for industrial-grade energy production. After finishing a meal, the biggest problem he faced wasn't natural enemies, but breathing. Think about it. With a 100-ton body, how big would the lungs need to be? Ordinary breathing methods simply couldn't provide such a massive frame. With enough oxygen, research by scientists has found that Argentinosaurus very likely possessed an air sac system similar to that of modern birds. Normal animal breathing is bidirectional. Inhale in, exhale out. With every breath, there is always some residual waste gas left in the lungs. The oxygen utilization rate is only about 25 fun-to-ram. But birds are different. A bird's air sac system allows air to flow in a single direction through the body. The fresh air breathed in and the waste gas breathed out travel through completely different channels. The oxygen utilization rate is close to 100 fun-to-ram. There are many pneumatic structures in the vertebrae of Argentinosaurus. These cavities are the traces left by the air sac system. In other words, this giant beast from 95 million years ago used the exact same breathing technology as today's eagles. He wasn't just a dinosaur. He was a precision machine that had evolved tens of millions of years ahead of its time. Speaking of this, you might ask, did something this big have any natural enemies? Yes, and they were top-tier killers in every sense of the word. In Cretaceous South America, there lived 2 terrifying predators. One was called Giganotosaurus, and the other was Maposaurus. Giganotosaurus was nearly 13 meters long, with a bite force exceeding 10 tons, even more ferocious than a Tyrannosaurus rex. Its teeth were like serrated daggers, specifically designed for tearing muscle. Maposaurus was even more formidable. It didn't act alone, but hunted in groups, just like a wolf pack. They had a clear division of labor, taking turns to harass the prey until it was driven to exhaustion. Facing these 2 types of killers, what did Argentinosaurus do? His first line of defense was his size itself. The hip height of an adult Argentinosaurus exceeded 7 meters, equivalent to 2.5 stories high. Even if a Giganotosaurus jumped, it couldn't reach his vital areas. It could only bite the legs. But the legs had skin 10 centimeters thick, with a layer of tough fibrous tissue underneath. Even if bitten through, it wouldn't damage the bones or internal organs. His second line of defense was his tail. The tail of Argentinosaurus was nearly 15 meters long, with tail muscles accounting for 15 fun-to-ram of his total body weight. The The bones at the end were thick and hard. The impact force when swung could reach 20 tons. What does 20 tons mean? A fully loaded heavy truck is about that weight. When he swept his tail, he wasn't just hitting you. He was slamming you with a truck, the Giganotosaurus. Ribs under such a strike would snap like dry twigs. So the reality was, it's not that predators didn't want to eat Argentinosaurus. It's that they simply didn't dare to act lightly. Most of the time, they would only target juveniles or injured elderly individuals. For an adult Argentinosaurus, they could only watch from afar and then quietly walk away. But even the most powerful life has its Achilles heel. The greatest weakness of Argentinosaurus wasn't natural enemies, but reproduction. His breeding rate was desperately slow. A female Argentinosaurus only produced one egg every 2 to 3 years. Not a clutch, just one egg. This egg needed to incubate underground for nearly 3 months. The hatched juvenile weighed only 5 kilograms, about the size of a small dog. Then he needed 15 years. To grow from 5 kilograms to 75 tons, it took 15 years just to reach adulthood. During these 15 years, he could be eaten by predators at any moment, starve to death due to insufficient food at any moment, or vanish because of a disease or a single accident. And his mother could only produce another offspring every few years. Do you understand now? This largest land animal on Earth had a reproductive capacity even more fragile than a giant panda's. This is where the deepest tragedy of Argentinosaurus lies. He bet all of his evolutionary resources on his size: bones, heart, breathing, digestion. Every system was optimized to the extreme to support this 100-ton frame, but the price was that he lost all room for error 95 million years ago. The climate of South America was warm and humid, with vegetation coverage as high as 90 terrain. The oxygen content was nearly 4 percentage points higher than it is now. No competitors, no food shortages. This land was like a paradise tailor-made for Argentinosaurus. In such an environment, he lived incredibly well, reigning supreme for nearly 10 million years. But about 66 million years ago, everything changed. An asteroid over 10 kilometers in diameter, traveling at 20 kilometers per second, slammed into what is now the Yucatan Peninsula in Mexico. The energy generated by the impact was equivalent to 10,000 times the simultaneous detonation of all the world's nuclear weapons. The dust kicked up by the impact shrouded the skies of the entire Earth. For several years, there was no sunlight, and plants died off on a massive scale. The death of plants directly caused the dinosaur food chain to collapse. For ordinary animals, if food decreased, they could eat a little less. They could migrate, they could change their diet, and they could survive. But the Argentinosaurus could not. He had to consume nearly a ton of vegetation every single day. A ton, not a single kilogram less each day. His body was simply too massive. He could not migrate quickly. His digestive system was too specialized. He could not change his diet. His reproduction rate was too slow. He could not replenish his population numbers rapidly. The very moment the vegetation began to dwindle, the fate of the Argentinosaurus was already sealed. He wasn't killed by an asteroid impact. He was starved to death by his own perfection. This is the cruelest side of nature. Extreme adaptation often implies extreme vulnerability. When the environment is your friend, you are an invincible king. But when the environment becomes your enemy, every advantage you have meticulously crafted becomes the weight that crushes you. The Argentinosaurus used 10 million years of glory and his ultimate total extinction to teach us a truth. True strength is not about optimizing yourself to the extreme, but finding that delicate balance between extreme specialization and flexibility. Those lives that survived after the asteroid impact were not the strongest, nor the smartest, but the ones most capable of adapting to change. A small mammal, weighing less than 1 kilogram, had been trembling at the feet of the Argentinosaurus for tens of millions of years. Eventually, his descendants stood at the pinnacle of this planet, while that giant beast whose single step could make the Earth tremble is left with only a few bones, lying quietly in the soil of Argentina, waiting for the next human to stumble upon it.